Let us begin with the next module of evaluation design and its components, beginning with research design. Research design is the set of research methods and techniques chosen by a researcher to conduct a study. Simply put, when we discuss a strategy to collect, study, and evaluate data, we talk about research design. This enables the researcher to identify problems, leading to the creation of a consistent and logical model for data analysis. Research design has a set of characteristics that allows the researcher to avoid errors and present the desired outcome, such as the following. Number 1, neutrality. The results which are projected from the research should be free from bias, both internally and externally. Number 2, reliability. The research plan should indicate how the questions are formed to endure the standards of results. Number 3, validity. It is important that the correct measuring tools are used to gauge results according to the objective of the research. Number 4, generalization. The outcome should apply to population and not just expected sample. But let us discuss why we need to prepare a design for research in the first place. The design provides a firm foundation. It reduces uncertainty and confusion about the research problem. Research design is helpful for collecting the research materials. It gives an idea regarding the type of resources required in terms of money, human resources, time, and efforts. It guides the research in the right direction and many other factors that prove beneficial to the direction and outcome of the research. A researcher must clearly understand the various types of research design to implement for a study. The design of the analysis can be classified into causal, descriptive, and exploratory designs. Causal research can be understood as a type of conclusive research that attempts to establish a cause and effect relationship between two or more variables. This type of research is widely employed by companies and corporations. It assists in determining the impact of the change in process and the existing methods, narrowing down the cause and effect relationship. For example, we can consider how much COVID-19 has impacted the global economy. Descriptive research can be described as a phenomena and its different characteristics to gain a deeper understanding of what it is without addressing why or how it happens. This type of research enables the researcher to get a proper understanding of a research problem before beginning to investigate it. An example could be tracking changes in the global economy in the post-COVID-19 situation. Exploratory research is a design that is used to investigate a research problem that is not clearly defined or understood, which enables the researcher with a deeper understanding of the problem and its context before research can be carried out. The implications of COVID-19 on the global economy can be considered as an example for the same. Here is an overview of a research design for your reference. To determine the cause and effect relationship between factors, there are two research methods within the causal research design. On the screen is a table that summarizes the similarities and differences between an experimental and a quasi-experimental study design. As you can see in the table, both experimental and quasi-experimental methods have similar objectives, which are to evaluate the effect of an intervention or a treatment. However, there are many differences in both these research methods when it comes to factors like the selection of participants, control group, room of confounding, level of evidence, their advantages, and limitations. Impact evaluation is an assessment of how the intervention being evaluated affects outcomes, whether these effects are intended or unintended. For impact evaluation, we will need to consider certain factors. The objective of impact evaluation is what is the impact or causal effect of a program on an outcome of interest? Here, the central question would be the magnitude of change and the attribution of change. But what is the importance of impact evaluation in a study? The need to use impact evaluation can be determined by considering if the program has achieved the intended goals and the kind of policy decisions needed in order to expand, modify, or eliminate a program. This in turn brings about the question of how the changes would impact the treatment group without the program. We will then require a counterfactual or comparison group identical to the treatment group to establish causality, attributing changes to the treatment. Now let us understand what is meant by a counterfactual group. A counterfactual group can be understood as a group of non-participants, which is statistically identical to the participant group in the absence of the program. This enables the researcher to understand what would likely have happened to the members subject to the intervention had they not been exposed to the counterfactual case. The program would be ideally identical to the treatment group in observable and unobservable characteristics, and this treatment should be the only difference between an ideal comparison and a project group. Process evaluation ascertains whether program activities have been carried out in accordance with the planned outcomes. It helps to understand the mechanisms involved in the creation of successful programs that achieved the intended outcomes, and these programs can be reused and developed for other contexts. It can also be used when a program does not achieve the objectives for the targeted populations. So periodically, over the duration of the program, process evaluation can be done to analyze the logic model's input and output components. The central questions of process evaluation would be to track two things: the magnitude and attribution of change. Why is it important to use process evaluation in a study? This method of evaluation is used for the researcher to be able to report on the program and utilize the information to improve the subsequent actions because of the findings of a process evaluation. This method also enables the researcher to keep track of the who, what, when, and where information about the programs, such as what would happen to the treatment group without the program, or who was the target of your program efforts, or when did the activities for the program take place. Randomized control trial is an experimental form of impact evaluation where intervention is the only difference between the two groups, such as that one group receives the intervention that is being tested, whereas for the other group, they are receiving an alternative treatment. This form of design, considered the most robust of all evaluation methodologies, involves gathering a set of equally eligible individuals willing to participate in the program and randomly dividing them into treatment and control group. The control group for this method is generated through random assignment to serve as the perfect counterfactual, free from selection bias. This randomization of groups depends on the level at which the program is implemented, such as through individual level randomized control trial and cluster RCT, such as the village level, school level, etc. The diagram on the screen explains how the random selection and random assignment is carried out for a study. Randomized control trials are prospective studies that measure the effectiveness of new interventions or treatment. RCTs are the gold standard for studying causal relationship because it involves randomization. The act of randomization balances participant characteristics between groups. This enables the reduction of bias and provides a rigorous tool to examine the cause-effect relationships between an intervention and outcome. On the other hand, this method of research has certain limitations, such as having ethical issues involved in the implementation. It is also an expensive method that requires an abundance of time and money while also having a risk of contamination or spillover of the gathered information. RCT has a method or implementation strategy called the stepped wedge design, which is used in special cases where the program would be implemented in a phased manner. A stepped wedge design is a type of randomized control trial that is used to evaluate the effectiveness of an intervention. It is used when it is not feasible to randomly assign participants to the intervention or control group at the same time. In this design, the group of participants are randomly assigned to receive the intervention at different points in time. This allows for the collection of data on the intervention's effectiveness over time, as well as the identification of any potential confounding factors. Stepped wedge designs can be a useful tool for evaluating the effectiveness of interventions in a variety of settings. To have a clearer understanding of the stepped wedge RCT, let us look at an example. For instance, let us try to estimate the use of technology in increasing learning gains. Firstly, we need to assume that the program will run for a period of 3 years. In this program, there will be a group of 300 students who are randomly selected from a school and divided into 3 groups of 100 each. Now suppose the first group was given a tablet with preloaded educational content in the first year. The second group was given a tablet with content in the second year. Finally, the third group was given the tablet with the content in the third year. To track the effects of the tablet distribution among the 3 groups, we need to measure the learning levels of each group every year. We will find that in the first year, the difference between the first and second or third group was the impact due to the intervention for 1 year. Consequently, in the second year, the difference between the first and second group was the impact after 1 more year of intervention, whereas the difference between the first and the third group would be the impact of giving the technology for 2 continuous years. And finally, this method would ensure that by the third year, all students would get the technology. Now let us understand the method of quasi-experimental design. The quasi or semi-experimental designs are experimental designs where the allocation of treatment is not random. This type of research design aims to establish a cause and effect relationship between an independent and dependent variable. In comparison to other methods such as experimental or randomized controlled trial, the quasi-experimental designs are less robust. The control and treatment in this method are also not randomly distributed, which might give rise to bias. In this method of research design, various techniques are used to create a counterfactual, depending on the stage of program implementation and data availability. The difference in difference method is a quasi-experimental approach that compares the changes in outcomes over time between a treatment group that is part of a program and the comparison group that is outside of the program. This method involves comparing 2 groups, one that receives a treatment and another that does not, before and after an intervention takes place. The difference in difference outcomes between the 2 groups is then analyzed to determine the impact of the intervention. The outcomes of both groups before and after the intervention are also compared to see if there was any change over time. To conduct the study, it requires at least 2 cross-sections of data pre-programmed on treatment and control groups. Finally, difference in difference cleans all time-varying factors such as selection bias from the first difference by subtracting the second difference from it. To have a clearer understanding of the concept, let's take an example of estimating the use of technology in increasing learning gains. First, let's assume that instead of randomly selecting students, every student of one school, let's say A, was given the content-loaded tablet. In this case, you do not have a proper counterfactual. Therefore, you randomly select some students for school A and some other school B, which you believe shares some similar characteristics. Now we need to establish a pre-post design in both cases. There's another approach to quasi-experimental research known as matching. This approach requires both the representative and comparable data for the treatment and comparison groups. The propensity score or probability score of the 2 samples based on the selected observable characteristics needs to be calculated. We need to restrict the sample to the units where common support appears in the propensity score distribution. For each enrolled unit, one has to locate a subgroup of non-enrolled units with similar propensity scores. When we compare the outcome of the treatment group with their matched comparison group, we will be able to find the difference in the average outcomes of the subgroups, and that it is the measure of the impact that can be attributed to the program. The mean of these individual impacts yields the estimated average treatment. Let us understand the concept of PSM by looking at this fictitious scenario to understand its implications. The table implies the scenario which has resulted in the following implications while taking into account the indicator of the households in treatment areas against the comparison areas. Regression discontinuity is another approach of quasi-experimental research. It is an approach that is used for programs that use a continuous variable to index, to rank potential participants in a program. This method can be used when there is some kind of criterion that must be met before people can participate in the intervention being evaluated. There is a cutoff point or threshold along the variable which is used to determine the eligibility criteria, that is, whether a potential participant receives the program. For example, the poverty score or index generated based on the judge assets to deciding PPL households, pension programs based on retirement age cutoff. Here, the candidates just below the cutoff point are like the candidates just above the cutoff point. So, it can be treated as the control group. Now let us understand what regression discontinuity design, RDD, is. It is an impact evaluation method that can be used for programs that have a continuous eligibility index with a clearly defined eligibility threshold. It determines who is eligible and who is not. For a researcher to use this approach efficiently for a study, they must be mindful of meeting the following conditions. The index must rank people or units in a continuous or smooth way. The index must have a clearly defined cutoff score, that is, a point on the index above or below which the population is classified as eligible for the program. The cutoff must be unique to the program of interest, that is, there should be no other programs apart from the program to be evaluated that uses the same cutoff score. The score of a particular individual or unit cannot be manipulated by enumerators, potential beneficiaries, program administrators, or politicians. Among the many approaches of quasi-experimental research designs, as we have already come across, there is the instrumental variable approach. This type of approach is one that overcomes androgeneity. It is applicable in the case of programs having universal coverage and voluntary enrollment. When conducting the instrumental variable approach, the program administrator cannot control who will participate in the program. For example, skill development missions and job training programs. The randomized promotion is an instrumental variable that allows us to create variation between units, and this variation can be used to create a valid comparison group. To conduct this method, there needs to be 3 types of participants, which are based on their intrinsic characters and cannot be measured by the program evaluator. These groups are namely never enroll group, always enroll group, and enroll if promoted group. In this study, the impact is measured based on the enrollment of promoted group. The counterfactual in this approach can be created by a random distribution of this variable in treatment and control groups. For example, an outreach worker would randomly select the individual to whom they visit and explain the program to. For this approach, the assumptions that are important for the study are as such. The instrumental variable should be effective enough to increase enrollment substantially amongst enrolled if promoted group. The promoted and non-promoted groups must be comparable. Promotional activity should not affect the outcome of interest. The instrumental variable of quasi-experimental research can be understood with the help of the following diagram. In this example, first, one needs to identify the population which is eligible for such an evaluation. Out of the eligible population, the evaluation sample is then drawn out. Following these steps, two groups are identified. That is, treatment group, where the promotion is done, and the control group, where no promotion is done. After this, enrollment is listed. Finally, when the evaluation is taken over, it turns out that the promoted group leads to 80% enrollment, and the non-promoted group leads to 30% enrollment. This ultimately leads to an impact of 50%. Apart from experimental and quasi-experimental designs, there also exists another set of research techniques called the non-experimental designs, NED. Now let us understand what it entails and how it can be used for research purposes. So, non-experimental designs are impact evaluation designs that do not include a matched comparison group. This type of research lacks the manipulation of an independent variable, so rather than manipulating it, the researchers conduct non-experimental research to simply measure variables as they naturally occur. Here, the outcomes and the impacts of the program are assessed without a conventional counterfactual to address the reasons behind the study. Now let us understand some potential NED that can be used for research. Number 1. Pre-test post-test design. In this type of NED, the evaluators will survey the intervention group before and after the intervention. However, in this approach, even though we are able to track the changes in the outcome through observation, it cannot be attributed to the intervention. Number 2. Time series designs. In this approach of NED, the researchers can look for changes over time that will enable them to determine the trend. The evaluators will observe the intervention multiple times before and after the intervention. This will help in the analysis of trends for before and after. Third is longitudinal study. This is another type of time series design. For this, the researchers repeatedly examine the same individuals to detect any changes that might occur over a period of time. Here, the researchers collect the same variable over time without trying to influence these variables. Under longitudinal design, there is a special type of approach called panel design. This method involves taking the same measures repeatedly from the same samples, often a small group, at different points in time to detect the changes and record their experiences in greater detail. There are advantages and limitations to using non-experimental designs for a study. The approach has an advantage of being versatile, which can be used to observe many unique phenomena while analyzing the collected data from the past to the present. It can also be far more affordable to use this design in comparison to the experimental kind. In order to make NEDs more efficient and strengthen the use of this method, we can take certain measures. The evaluators should measure the participants' level of exposure to the program. So if the participants with higher exposure show higher change in outcome indicator, it will strengthen the argument of the program leading to the change. Therefore, it is important to control the variables statistically to accurately measure the variables of interest. One can collect data from the same participants over time using the longitudinal study. Here, the characteristics of the individuals can be controlled based on real time, while eliminating the risk of recall bias and allowing an insight into cause and effect relationships.